For this first video, we will be exploring fractions, especially the many names of fractions, and what a fraction actually means. Fractions are oftentimes described as I'm going to make this a little bit smaller font, as a part of a whole, with that whole being referred to with the special name of a denominator, and the part being denominator, and the part being referred to as the numerator. Now, fractions are arguably the most important concept to understand in math in order to be successful. So, and one of the main problems that students often encounter with fractions is that they can come in so many different names that mean essentially the same thing. So I'm going to put a fraction out here, and let's say the part in this case will be 2, and the whole part will have 3 pieces. So we're looking at the fraction 2/3. The denominator is 3, the numerator is 2. So to show you a visual of what this looks like, we take this whole thing, and in the whole thing we say there are 3 parts. So I'm going to draw 2 lines, and that will give us 3 parts. Now, of those 3 parts, 2 of them will be shaded, or 2 out of the 3 parts. So you'll often see fractions represented with this rectangular model, or you might see them with something that looks like this. And with the circular model, this means the same thing. Right now you see 2 of the 3 parts are shaded, and this means 2/3. Let's explore this a little bit deeper right now to discuss the many different names of 2/3. So what else does 2/3 mean? Well, it comes in many different names. Think of this kind of like a nickname. My name is Howard, yet I go by Howie. People can call me a lot of different other things, but in the end of the day, I'm still me. So no matter what you're calling me, whether it's my nickname or my whole name, they mean the same thing. So take something like 2/3, and I'm going to continue out with this model of looking at the circles, because I think that makes it a little simpler to see. So we see that this is 2/3. What does this mean? This means that every time we add a group of 3, or 3 circles in this case, 2 of them will be red. So and in fractions it has to be the same rate. So let's keep going at this rate. Every time we add 3 circles, or every time we add a block with 3 parts, you would shade in 2. In this case, I'm going to work with circles. So every time we add 3 circles, 2 of them will be red. Now, you can see we just kept going by 2/3, but now think about how many is in the whole group. Now, it's not just out of 3 circles, with 2 being red, but now there are 6 circles in all. So now the denominator is 6. What is the numerator? Well, now instead of being 2 red circles, there are 4 red circles. A big misconception people often have is they think that this 4/6 is actually bigger than 2/3. This makes sense because 4 is larger than 2 and 6 is larger than 3. But in fact, They are equal. Why are they equal? Because they still are moving at a rate of 2 out of every 3 circles are red. And so no matter how many we add, if it continues to be 2 out of every 3, they'll be equal. And we can go on and on and on in this pattern. And you could find many other names for this same fraction. To do this, continue increasing by a group of 3 circles with every 2 being red. So we get another fraction, which means the same thing because they're moving at the same rate. 2 out of every 3 are red. But the name for this fraction would now be the whole, or the denominator, is now out of 9 parts. So we say it's out of 9, and 6 of them are red. These are the many names of fractions, and they're all the same thing. 2/3 is equal to 4/6, which is equal to 6/9. Oftentimes, you might see a sort of a problem that will look like this. And it might say 2/3, which is exactly what we've been working with. So I'm going to write 2/3 back up here. And it might say 2/3 equals, and it might give you the denominator. It might say 2/3 equals, and I'm just going to write this in, how many out of 21? There are 2 ways to go about this problem. Well, we saw that 2/3 is equal to 4/6 and is equal to 6/9, and we found that by continuously increasing this group by the denominator, groups of 3, and every time we increased a group of 3, we shaded 2, or 3 circles, and 2 are red. So you can continue to do that until you get to denominator of 21, and right now, remember, we have a denominator of 9. So you can keep adding 3 parts. Alright, so I'm going to add another 3 parts, and 2 will be red. And you can continually write this down off to the side to help you keep track. So now we had a group of 9, now we have a group of 12. And now 2, 4, 6, 8 of the 12 are shaded. So you can keep adding that, and next we would have a group of 15, then 18, then 21. So you can work your way up, or you can think to yourself, I'm starting with a group of, and this is the much shorter way to do it, which is probably recommended. You could think to yourself, I'm starting with a group of 3 in the whole. The denominator is telling me that I need to wind up with a group of 21. You can think to yourself, how many groups or rows of 3 will I need to get to 21? Well, with 1 row, you have 3. 2 rows we saw would be 6. 3 rows, 9. 4 rows. Well, you will find out, and if you kept this pattern, that you need 7 rows. You could think, instead of drawing it all out, to go from a group of 3 to have 21, how many 3s will it take, or how many rows of 3? 3 times 7 is 21. So you will need 7 rows of 3. When you're working with fractions, both the numerator and the denominator, in order to be equivalent, need to be adjusted at the same rate. So if you multiply, or you're saying you have 7 groups of 3 in the denominator, then that means you would also have 7 groups of the numerator, which is 2, or 7 groups of the red circles. So if you have 7 rows, then in the 7 rows, each row will have 2 red circles. So you need to multiply both sides by 7, which is why I often say whatever you do to one side, you must do to the rest. That's when working with fractions because it keeps it equivalent. So in the end, you'll find out you have 14 out of 21 are red. A great site to practice this concept, and I'm just going to highlight and delete all of that. A great site to practice this concept is on the website visualfractions.com. And if you go to the website visualfractions.com, go to rename, and I believe it would be rename higher rather. And you could do lines or circles. For the first one, I'm going to do lines. And hit start, and it will generate a problem for you. Like 4/5 equals how many 25ths? We can do this problem off to the side. I'm just going to remind you of the 2 ways. You could set it up as an equivalent fraction like this and think to yourself, to go from a group of 5 to a group of 25, well, how many groups, to go from 5 to 25, how many groups of 5 will it take? Or how many rows of 5 will it take to get to 25? Or you can actually draw it out. And in this problem, I'm just going to duplicate, duplicate, duplicate. So we have 4 out of 5, let's say, are red. How many out of 25? And you could see to yourself that in each row there are 5, so you're going to need 5 rows. 5, 10, 15, 20, and 25. 5, 10, 15, 20, 25. And in each row there would be 4 reds. So you're multiplying the number of rows times, or the number in each group, times 5. Because you're going to need 5 rows of 5 to get to 25 total. Whatever you do to one side, you must do to the rest. And you could have recognized that right off the bat. I'm going to need 5 rows to get to the denominator of 25. And you would find that it's 20 out of 25. And so up here on the website, you would just write 20, you would hit OK, and you would see that you are correct. That's the first part. In the second part, we'll now talk about renaming and getting smaller, which is an even harder skill.